Alright, we're ready to begin our exploration into the gyroscope on this SenseHat module that's attached to a Raspberry Pi. So the first thing that we need to do is get Scratch started. So up in the upper left, if we click on the Raspberry icon and choose the programming menu, we have the Scratch 3 development environment. So we'll click that. It'll take several seconds for the desktop to load, so we'll wait for that to happen. All right, nearly there. So this is our Scratch desktop. Now, since we want to work with a SenseHat, we need to install an extension for that. So down here in the lower left, there's a button called Add Extension. And if I click on that, it's going to show me all of the different kinds of extensions that I can add to Scratch. So I'm going to pick the one that says Raspberry Pi SenseHat, and I'm going to click that one. And you'll see that it's now added another set of controls to Scratch, and these are all things that I can do either with or to the SenseHat module. All right, I now want to test to make sure that the SenseHat is working properly, and to do that I'm just going to take this one that says Display Picture and drag it to the center and then click on it. And if your SenseHat is connected to your Raspberry Pi and working properly, then the LED matrix on the top of the SenseHat should have lit up in a configuration that looks like this. It's the Raspberry Pi icon displayed all in white. All right, if that happened, then we're all set, we're good to go, and we now want to just clear the display. So I'm going to drag over the Clear Display block, click on that, and that should make the LED matrix go back to being dim. So now that we've asserted that the SenseHat is working properly, I'll drag the pieces back to the pieces bin, and we'll be ready to set up our stage. All right, to explore our gyroscope, we're going to use a rocket instead of the cat. So I'm going to delete the cat sprite by clicking on the trash can. And then down in the lower right, there is a Choose a Sprite button. So I'm going to click that. And then these are all of the sprites that Scratch provides. It's also possible to create your own sprites, but I'm going to choose a rocket. I'm just going to type rocket in the search box and it'll bring up the rocket ship. I'll click on that. All right, so it's put the rocket ship on my stage, but this rocket ship's a little bit too big for me. So I'm going to change it from 100 to 50. That'll make it about half its original size. And then I'm going to change its location to 0, 0. That'll be right in the middle of the stage. And then I'm going to just take note of the fact that my direction is 90. And you see that our rocket ship is pointing straight up. So we're going to assume that whenever direction is 90, the rocket ship is pointed upwards. And we're going to change the direction based on movements that are detected by the gyroscope with the SenseHat. Now, our rocket ship would look a lot better if it were in space rather than just on a white stage. So if I go to the Choose a Backdrop button in the lower right, and again search for space, you can see there's lots of different space backgrounds already available. So I'm going to choose the stars, but feel free to choose any one of the ones that you want. Or just like with the sprite, it is possible to create your own backdrops. So we've got our rocket. It's appropriately sized for our stage. It's in the center because we set the X and the Y both to 0, and it's pointed up, which again is 90 degrees. All right, so now we need a way for the SenseHat to tell us which way it thinks it's moving. All right, so we're going to set a couple of the little squares. Now the squares are called pixels to a particular color. So I'm going to start by dragging from the Sense Hat control area a set pixel XY to a color. Now I want to set this pixel and this pixel in the top row. Now, just like a sprite had an X and a Y direction that determined where it was on the stage based on the center, the LED matrix can be programmed. Each square can be identified by an X and a Y coordinate. The X indicates how far to the right we've gone, and the Y indicates how far down we've gone. Now, you'll notice if I drop this down, it only has values 0 to 7. Well, if you count the squares, you'll see there are 8 in both directions. I have 8 across and 8 down. But numbering for this matrix, or this square set of squares, starts at 0. So 0 is the first square, 1 is the second square, and if I'm going to the X, it's to the right. So 0, 1, 2, 3, 4, 5, 6, 7. For the Y, it's the same. 0 is the top row, 1, 2, 3, 4, 5, 6, 7. Now, I want to set this one and this one. So that is 0, 1, 2, 3, and 4. So I'm going to set, whoops, not Y, sorry. I'm going to set the X to 3, and I want the Y to be 0 because I want the top row. So the first row has an index of 0. And I'm going to use a green color, but feel free to use whatever color you want. So I'm going to set my green to color 36. Okay. And now if I click this, it lights up there. Now I forgot to mention, I'm using what's called an emulator. All right, so this pretends to be the real Sense Hat. With your Raspberry Pi and your Sense Hat, when you click on this control with 3, 0, and a color, it should actually make that square on your LED matrix light up. So I want to set another pixel. This time I want the fourth one, which will be the one right next to the third one, and I'm going to also set it to 36. Okay, so now if I click it, they both light up green. And again, if you click those, they should light up green on your LED matrix on your Sense Hat. Now, I'd also like to ensure that the screen is always cleared when I click these. So I'm going to add a clear display block to the top. Okay, now when I click it, it will make them go away and light them back up. I can't really tell the difference because I'm lighting up the same 2 pixels. All right, but if I duplicate this block, I simply right-click and duplicate and stick it over here. So we'll say that that's the forward. We're going to attach that to forward in a minute. This one's going to be backward. Okay, so backward, I want these 2 to light up. All right, so what Y number do you think I need to give it for these 2? It's the same X because I'm still in the 3 and the 4 square going from the right, or from the left to the right. 0, 1, 2, 3, and 0, 1, 2, 3, 4. But now I'm down here at the bottom. Well, if you'll remember, the last row has the number 7. Okay, so now when I clear the display, it'll light up the bottom 2. So I'm going to duplicate that again. Now I want to light up the 2 on the left. All right, so now I'm in the first column of the X, which had the number 0. And I want to go 0, 1, 2, 3 down and 4 down. So I'm going to say 3 and 4. And when I click on that, now the ones on the left should light up. All right, so what do you think I need to do to the ones on the right? Well, the Y's are going to stay the same. I'm going straight across, so I'm in the same rows. But now instead of the 0 column, I want the last column. So the last column is 7 for X. All right, so now we can light up whichever set of squares we want based on what direction the sense hat is being tilted. And we have controls for that too. We have a when tilted control. So I'm going to drag that up to the top of this. Now when it's tilted forward, that's when I want the top 2 pixels to light up. All right, now I clicked it. With your real sense hat, you should just be able to tilt it forward, and that should make these two pixels light up. So we're going to add the same thing to the next one. All right, but this one was the 7 row, so that's at the bottom. So that means I want it to be backward. All right, now again, I'm going to click it, but you tilt it. All right, same thing for left and right. And again, if you tilt it left, the left 2 should light up. When you tilt it right, the right 2 should light up. So now, whichever way you're tilting the sense hat, the LEDs in that part of the display should light up. Now, we also want to have a way to clear all the lights and turn it back to the point where they're all turned off. Okay, so we're going to go to the events bucket, and we're going to grab the when green flag clicked. That just basically says when I click this button over here, I want to, that's the wrong place, I want to clear the display. Okay, so now if I click the green flag, they all turn off. But then if I tilt it forward, the top 2 come on. If I tilt it right, the right 2 come on. If I tilt it left, I tilt it back, click the green flag. All right, so now we know which direction is forward, backward, left, and right when we tilt our sense hat. So next we want our rocket ship to respond when we tilt the Raspberry Pi and the sense hat module. So when we tilt it forward, we want the rocket ship to go up on the stage. And when we tilt it backwards, we want it to come down. Now, if I look over here in the sprite control panel, I'll notice that there is an up and down arrow next to Y. All right, so the Y value, whatever number is here, determines how far up or down the stage the rocket ship is positioned. So if I make the Y value 50, the rocket ship jumps up. If I set it back to 0, it comes back down. Now, if I want it to go backwards, I use negative numbers, all right, less than 0. So I'm going to say negative 50, and it jumped down the screen. So we're going to use those concepts to change our controls over here so that when we tilt it forward, the rocket moves up, and when we tilt it backwards, the rocket moves down. So I'm going to start with a motion block. All right, since it's the Y coordinate or the Y value that I want to change, I'm going to say change Y by, and we'll just use the same 50 that I was using a minute ago. So now when I tilt the Raspberry Pi and the sense hat forward, the rocket jumps up. If I tilt it forward again, it jumps up again. But now I need it to come back down the screen. All right, that's still movement in the Y direction. So I'm going to say change Y by, but this time I want it to be negative 50. All right, so that moves me in the opposite direction. And I'll go down 50, down 50, down 50. And if I tilt it forward, I go up 50. All right, so that gives me basic motion up and down. All right, we're going to do something similar then to the left and the right. Just like the Y controls up and down, X controls left and right. So if I say 50X, where do you think that's going to move me? Well, that's going to move me 50 to the right, positive direction. But if I say minus 50, it's going to move me to the left. And if I go back to 0, it'll put me back in the middle. Okay, so to accomplish that with the Raspberry Pi, I simply need to take my change x by, and when I'm going left, I want to move in a negative direction. So I'm going to say minus 50, and then when I'm moving right, I want to go in a positive direction. So we'll say plus 50. So now I should be able to move my rocket ship in all 4 directions. I can move them in any order. Every time I tilt, it moves 50 in whatever direction I tilt it. So our rocket ship now can move, but it only moves a certain amount every time we tilt. So we tilt once, it goes 50 up. If I tilt to the right, it goes 50 to the right. Tilt right again, it goes 50 more to the right. What I would really like to happen is that for as long as the device is tilted, I want the rocket to continue moving in that direction. All right, and that will give us more of a fluid motion than what we have right now. So in order to do that, I'm going to do a couple of different things. First off, I'm going to say in the motion section, I'm going to take go to XY. I'm going to drag it down here right under clear display attached to when green flag clicked. And I'm going to set the X and the Y back to 0. So this is going to work like a reset button. Every time I click the green flag, it's going to put the rocket back in the middle of the screen. The next thing I need to do is add a variable. Now, a variable is just a way to keep track of information that might change as the program is running. So I'm going to create a variable. I'm going to call my variable direction. I'm going to say that it's for this sprite only. Now for this particular program it doesn't matter very much because I only have one sprite. Alright, and you see now I have rocket ship direction 0. Well, I don't want it to be 0. I want to give it something that's a little more meaningful. So I'm going to drag this set direction block. I'm going to attach it to go to 0, 0. And I'm going to say that I want my direction to be stopped. Okay, so now when I click the green flag, I'll go to 0, 0, and my direction is stopped. Okay, that means just not moving. Now, every time I tilt, I want to set that direction variable to the same direction. So I'm going to say that when it's tilted forward, I want the direction to be forward. And when it is tilted backward, I want the direction to be backward. When it's tilted left, I want the direction to be left. And when it's tilted right, I want the direction to be right. Okay, so now if I tilt my rocket, that's forward, right, back, and left. Now, it still isn't moving the way I want it to, but at least I now know what direction it's going, and I'm storing the current direction in the variable direction. Now, Scratch has a control block that will let me do something over and over and over again. All right, that's called a loop. Now, for me to put that in, I'm going to first drag the change Y by block away from when tilted forward, and I'm going to take this repeat until block. I'm going to put repeat until under there. All right, so basically this says when it's tilted forward, set the direction to forward, clear the display, set the 2 pixels at the top of the LED matrix to green, and then repeat until something happens. Now inside the repeat, I want to continue moving my rocket, but now instead of moving it in increments of 50, I really just want to increment in units of 1. But now I have to figure out what to put in the until block. So that's a diamond shape. I need to go to operators. That's where I find the ones that fit into the diamond shape. Now, if my direction is forward and I want to keep doing something as long as it is forward, I have to be a little creative with the way that I tell it, that I specify that particular condition. All right, there's not one over here that says repeat while it says repeat until. So for me to do an until, I'm going to have to say the direction is not forward. Okay, and then I need to repeat until not, and then I need a variable block, I believe. No, I need another condition block, an operator. And I need an equal. So this time I'm going to take the something equals something and put it, whoops, I didn't get it right into the not box. Alright, so now I have repeat until something is not equal to something else. The something I want to check against is the variable direction. So I'm going to go here and I'm going to take direction. Now notice it's in an oval, and since it's in an oval, I can drop it in that oval. And then in this oval, I just want to say forward. All right, so basically what I'm telling it to do here is repeat until direction equals forward is not true. Okay, so up here I set direction to forward, and direction only gets changed to something else when the device is tilted in a different direction. So what this should do is, when I tilt it forward, my rocket ship starts to slowly move up the screen. Now, if I tilt it backward, it stops moving. Well, that's because tilting it backward causes the direction variable to take on a new value. It now becomes backward. But over here, I was doing this only as long as direction was equal forward. So when direction equals backward, it's not equal to forward. And that stops my repeat block from executing. All right, so for me now to move the rocket ship backwards when the direction changes to backward, I need to do the same thing there. So I'm going to go to Control again. I'm going to get a repeat until. I'm going to go to Operators. I'm going to get the not operator. Then I'm going to get the equal operator. I'm going to make sure that the equal operator drops into the not operator, so now it's not equal to. I'm going to go to variables. I'm going to grab direction. All right, but now I want it to not equal backward. Okay, so now my new control is repeat until direction equals backward is not true. And now, instead of minus 50, I just want to go minus 1. All right, so now if I tilt my rocket ship backward, he starts to move down the stage. If I tilt it forward again, he starts to go up the stage. And backward, he comes down the stage. All right, I'm going to click the green flag to put him back in the middle and stop him from moving. So the green flag now acts like a reset because we cleared the display, we set the sprite back to the center of the screen, and we set the direction back to stopped. Now stopped is not equal to forward, and it's not equal to backward. So if either of these two loops were in the middle of executing, changing it to stop would cause either one of them to quit. All right, got to do the same thing for left and right. So I'm going to go to Control. I'm going to get a repeat until. I'm going to go to Operators, get a not, get a equals, drop equals into not, go to Variables, get direction, and now the direction I'm checking against here is the left direction. Now I'm going to put the change x by, and again, instead of going minus 50, I'm going to go minus 1. All right, now notice this was y, this was x, so now this is horizontal. So x minus 1 is going to move me left. And then lastly, I do the same thing to right, get repeat until, Go to Operators, get Not. Go to Operators, get Equal. Go to Variables, get Direction. Change 50 to right. Put the change X by back into the middle and put 1. All right, so now anytime I tilt forward, I go forward. If I tilt right, I start going right. If I tilt backward, I start going down. And if I tilt left, I start going left. And always the green flag puts me back in the middle and stops my ship from moving. All right, the next thing that I want to do is I want the rocket ship to change direction when I move it. So right now, if I move it forward, it goes forward. But if I move to the right, it kind of just slides to the right. I'd really like it to point to the right. That will make it look a little bit more realistic for me. I'd also like for this thruster part, the flame coming out the back of the rocket, to only show when the rocket is actually moving. So there's two things that I'm going to do. First, let's take care of the thruster. If I go up here to the left and say Costumes, I'll see that my rocket has multiple different versions of itself, different pictures that can be shown for the rocket. Now, this one down here, Rocket Ship E, doesn't have any thruster. Rocket Ship A has the thruster, and then B and C and D are simply rotated versions of A. So I'm only going to work with E and A. All right, E is no thruster and A is a thruster. So when the green flag is clicked, that's like when I reset the system, I want to change the costume. So I want the costume to be Rocket Ship E when I first click the green flag. All right, so that turns off the thruster graphic. All right, but that also means that when I go in any direction, I need to change the costume again back to Rocket Ship A. So for every tilt action, I want to add a costume change. All right, and now when I tilt forward, I get my thruster. And as long as I'm moving, I get my thrust. But when I stop, it goes back to the center and I don't have the thrust anymore. All right, so that's perfect. That's exactly what I wanted. Now, the next thing that I wanted to do is I want to turn the rocket in a different direction. So I'm going to go up to the motion section and I'm going to pull out a point in direction and just put it over here to the right for a minute. So if I click on point in direction 90, we said earlier that 90 was up. Well, let's see what happens if I say 0. So 0 is left. Now, when I click on the number, I get a little dial. And the dial says that 0 corresponds to pointing up. And if I rotate it around to the right, 90 corresponds to pointing to the right. Well, that's because in Scratch, a sprite up direction is 0 and the right direction is 90. All right, but it makes more sense for us to think of, for our rocket ship, the direction 90 being up, which means that 0 is to the left. All right, so if 0 is to the left and 90 is up, what do we think that to the right will be? Well, it should be 90 more than 90. So if I put in 180 and then click, the ship turns to the right. All right, that's perfect. Exactly what I want. All right, for me to continue rotating around to the right, I need to turn it another 90 degrees. Well, 90 degrees from 180 is 270. All right, but look what happens. It changed 270 to negative 90. All right, so to understand that, what we have to realize is that going from 0 in a positive or a clockwise direction, I go 90 degrees to the right, I'm pointing up. But if I go 90 degrees to the left, or a counterclockwise direction, I'm now pointing down. All right, so Scratch only works in values between 0 and 180. So 0 in our coordinate system here has the rocket pointing to the left, 180 has the rocket pointing to the right, 90 has it pointing up, and negative 90 has it pointing down. So we're going to use that information, and we're going to drag in the point in direction block to all of the tilts. Okay, when I tilt forward, I want the rocket to go up, and we said up corresponded to the 90 degree direction. But when I'm pointing backward or tilting backward, I want to point down. Okay, so that's the opposite of 90, or in our case, negative 90. All right, so we want to go from 0 over here down to 90, which is the counterclockwise direction, so that's the negative direction, minus 90. And then when I am tilting to the left, I want to point the rocket to 0, because that's what we said was the left direction. And then when it's moving to the right, I want to point it to 180 degrees. All right, so left is 0. If I go left, I'm pointing left. And then up was 90, right 180, and down or back minus 90. All right, so that's perfect. We've now got our rocket ship moving in, oh, and look, when I clicked the green flag, I stopped, but I didn't turn around. So I want to do that. So we're going to go up to our reset section, and when the green flag is clicked, and I want the rocket to point in the 90 degree direction when I reset. All right, so now I can move him, I can turn him, I can turn him, and whichever way I go, the rocket's going to follow my instructions. All right, pretty much like a game controller.